I'm Mallory Tevini from Haas Automation. In this video, I'm back here in the demo room to teach you about tool frames and user frames as they relate to our Haas robot packages. Understanding these concepts is critical before you begin programming a full robot job.
I know this video seems long, but tuning in and staying attentive throughout the whole video will be well worth your time. Both programmers and operators will benefit from hearing this information.
I'll start by showing you the basics on how to jog the robot, then talk about understanding the types of frames. Afterwards, I'll show you how to make custom tool frames and user frames. You'll notice that I'm using the HRP1, which is our smallest robot for this demo, but the software is similar across all packages. Let's jump into it. Since we are doing a setup task, the setup mode switch on the side of the control panel should be horizontal. After you've confirmed that, head back to the main screen and click the Current Commands button on the display options. Within the Current Command screen, we'll scroll over to the Robot tab and then to the Jogging sub-tab. After, grab your remote jog handle and make sure you're in Cartesian mode. You can change the mode with the setting on the control or using the touchscreen on the RJH in the bottom left corner. The other mode is Joint mode that allows you to jog the 6 joints of the robot independently. We will cover Joint mode more in depth in a separate video. For now, we like to be in Cartesian because each type of frame is comprised of 6 Cartesian components: X, Y, and Z linear axes, and W, P, and R rotational axes. W spins about X, P spins about Y, and R spins about Z. To jog the robot, you will need to be in handle jog mode and hold F2 on the RJH in addition to holding the arrow buttons or spinning the jog wheel. If you release F2 while spinning the jog wheel or pressing the buttons, the robot motion will stop. Now, let's go back to the control and move left to the Frames sub-tab. Frames are what define the coordinate systems that the robot uses to know where it is located, where to go, and where the parts it will be loading and unloading are located. We have 2 types of frames: tool frames and user frames. Simply put, tool frames define the coordinate systems for the tool. User frames define the coordinates for the robot and for the part setup. Let's do a quick comparison to understand the similarities and differences. Starting with the similarities, each type of frame is comprised of 3 linear and 3 rotational axes previously mentioned. Also, both types of frames come with a world frame activated, which I like to think about as the standard default that cannot be changed. Lastly, for either frame, the programmer can use the direct entry method to generate new frames with different orientations or different origins. Now, for the differences. The tool frame defines the coordinate system for the tool. It is crucial when you are adjusting the gripper orientation or placing a part in the work holding. The default origin is located at the center of the faceplane of joint 6, and therefore the coordinate system travels with the robot during motion. Ultimately, you want the origin to be located at the center point of your gripper, which is commonly referred to as the tool center point. Direct entry method is your only available method to make new tool frames. Flipping gears, the user frame defines the coordinate system for the robot itself, similar to setting a work offset. It is important when programming the motion of your robot that you can jog it in intuitive directions. For example, I always like my Z-axis to be pointing straight up and down when working with a flat parts table. The default origin is located at the intersection of the J1 and J2 axes of the robot. This coordinate system is stationary and therefore does not move as the robot moves. Your goal is to make a frame that makes programming the robot effortless, with X, Y, and Z being in predictable directions. Unlike the tool frames, you have 2 methods for creating new user frames: 3-point method or direct entry method. To conclude our comparison, think about your CNC machine and the relationship between the work offset, the tool offset, and the NC program. The work offset defines where the part is located, the tool offset defines where the tooltip is located, and the NC program defines the motion that links these 2 positions together. Similarly on the robot, the user frame defines the coordinate system for the work table surface and the robot itself. The tool frame defines where the robot gripper is located and how to rotate the part. and the positions you program in the motion files will link both these frames together. With all that being said, let's get into understanding the default frames a bit more individually, and then I'll teach you how to make new ones. Let's talk about tool frames first. Before making a new frame, I suggest jogging the default frame different ways to understand how it is moving and what you want to be different. Here in my specific setup, I'm holding F2 and jogging W in the positive direction. I see where it rotates around counterclockwise, and this tells me my X positive direction. I will do the same with P and R to identify my Y and Z linear axes. While I am satisfied with the directions of the rotations and axes, I would like to move the origin of the coordinate system to the center point in between the fingers of my gripper. This is helpful so that W, P, and R will all rotate about the center of my part instead of about the faceplate. It may not seem critical now, but it becomes more significant with larger or more complex grippers. To do this, I need to move the origin about 6 inches downwards. From jogging, I know that this would be a translation of 6 inches in the positive Z direction. To make a new frame with direct entry, as stated previously, you always input the linear or rotational changes you'd like to apply to the default frame. So, to create this new frame, I will hit enter, type in my desired name for the comment, and input 6 for Z, and then hit enter again. Because I did not input anything for W, P, or R, the orientation of my coordinate system did not change, but my origin was moved 6 inches in the positive Z direction. Make sure to activate this frame by pressing F2 on the control so that you can double check that it is rotating desirably. We can see now that the point of rotation is at the center of the part versus at the faceplate. Notice, by activating it in the Frames tab, the frame also becomes listed as active in the Jogging tab. If you have more complex end-of-arm tooling or a more complicated adapter plate, you may want to make additional changes. The linear adjustments will still be used to locate a proper origin of the tool frame, and the rotational adjustments will place the axes in a more expected orientation to the gripper. Let's do another example using this 90-degree L bracket. Based on how I've mounted the new setup, I know my tool center point is in a different location and orientation. I want to move the origin to in between the gripper fingers and make my coordinate system in the same orientation to my gripper as it was before. To do this, I need to move about -7.5 inches in the X direction and about 2.5 inches in the Z direction. Also, I need to rotate 90 degrees about the Z axis and -90 degrees about the X axis. Once again, I can activate this frame to ensure I did it properly. On the trickier ones, this sometimes takes a little visualization and guess and check, so do not get discouraged. New frames should be straightforward to the user, so there really isn't a one-size-fits-all way of doing it. That's it for tool frames, and now I'll do something similar with user frames. Like before, we can understand the default frame by taking time to jog various axes and note how the robot moves. However, there's a faster and easier option that I'll show you for our HRP1. I said previously that the origin of the default user frame is at the intersection of the axes that joint 1 and joint 2 spin around. We also know that the default X positive direction for this robot always shoots out opposite to where the cabling mount attaches to the robot. Therefore here, the default Y positive is a quarter turn counterclockwise from that, and the default Z positive shoots upwards off that plane. For the setup you see here, it's going to be confusing to program the robot at this 30-degree angle. To adjust this and make it more intuitive to use, I'll create a new user frame through direct entry by hitting enter. I want to change the direction of X and Y to be more natural for me while I'm programming, and I want my axes to lay flat on the table. I'll type in my desired name and input -30 for W and 90 for R, and then press enter. The 90 swivels the X and Y axis a quarter turn counterclockwise around the Z axis, while the -30 corrects for the 30-degree slope. With this frame activated, let's jog the X axis again to see now that it moves parallel to the tabletop and also moves between the fence and the machine. The Y axis moves towards me and the side fencing, and the Z axis moves straight up and down. This user frame is in a much more suitable orientation for my raw stock table setup.
But let's take a moment to further break down why I chose to make these specific changes step by step. I didn't add any values in the X, Y, or Z rows because changing the origin of the frame wouldn't be an advantage for me. But I did value putting the axes and directions that were the most intuitive to me, which meant that when I was facing the table, the X-axis would be from left to right, and the Y-axis would extend from front to back. To make this happen, I added a positive 90-degree value in the R row. You might be thinking that a negative 90 degree would achieve the same relative directions, but positive and negative do matter when you are programming a full robot job later. If you are doing a table grid part setup, the initial pickup location should always be at your lowest or most negative X and Y values. This is because, in simple mode, the distances you input for row and column spacing will always tell the robot to move that amount in the positive directions. Knowing where your robot needs to start and then being able to predict its directions is very important. So what about that dang 30-degree angle? To ensure my XY plane is parallel to my table surface, I need to rotate negative 30 degrees in W, and it will flatten out that plane. Now, I'm good to go. Let's think about a more straightforward example. What if all I wanted to do was flatten that angle out? Maybe I want the directions of X and Y of the robot to match the X and Y directions of the machine. In this case, that will happen once the slope is corrected. It is a simple fix this time. I could make this frame by pressing Enter for direct entry, typing in the name, and then type in negative 30 for P, and then enter again.
Personally, for most standard and flat setups, I will always use the direct entry method as I have just done. However, the 3-point method is good to know as well, especially if you need to reference a custom tilted plane, such as in a setup where you use gravity to help sit the parts properly in the template. Here, I've assembled a tilted plane to demonstrate what I would do. Begin by pressing Insert on the control panel and type in your desired name for the comment. Arrow to the right to proceed, and it will prompt you to record 3 points. The first being a simple orientation point. I will use the RJH to jog the robot to where my initial pickup location would be, and then record using F2. The next will be the X direction point. Your goal is to move the robot in what you want to be the positive X direction, and then touch off again. So in my case, I will move directly towards the machine. Of course, if you touched off directly on a surface, do not ruin your gripper by sliding it along a surface. To ensure you get an accurate frame, you can jog the robot above the surface as needed as an intermediate step, but make sure when you touch off and record again that it is back at the desired height. The last point is the Y direction point, and it requires a similar motion. In my case, my Y positive direction will be going up my known slope. I will hit F2 once more to record, and then Insert to make the frame. From these 3 points, the robot will use the right-hand rule to create a complete coordinate system, and I can activate it to ensure that my Z-axis is coming off normal to my surface. For now, that wraps up our lesson on tool frames and user frames. Thanks for watching, and have a great day.